poor spanning tree protocol. Virtual port channels edge it out of the data center, and something that takes it on directly is FabricPath. FabricPath literally eliminates the use of spanning tree protocol in a large switch, let's call it a switch cloud or a switch domain. We have all these switches, and they're able to eliminate spanning tree protocol altogether. Not just trick it, but eliminate it. Our focus will be troubleshooting FabricPath in this particular nugget after a quick review of some of the core technologies that make it up. It's really amazing for us old timers to think about spanning tree protocol being eliminated from the equation. So we have this domain, and this domain is filled with switches, and these switches are interconnected, and these particular switches are going to, instead of run layer 2 spanning tree protocol to eliminate loops, they're going to run what I like to call layer 2 ISIS. That's right, the comeback of intermediate system. This routing intelligence cooked into a layer 2 version is going to run inside this FabricPath cloud, and there will be no loops and no need for spanning tree protocol. Equal cost multipathing up to the maximum, which is the default, of 16 paths can be utilized so that we can have full redundancy even in this spanning tree protocol-less environment. Now, your particular equipment you would want to research to ensure full support for FabricPath. The 5500 certainly do it, the 7Ks with the F modules will do it, and that list will grow as FabricPath takes more hold. By the way, FabricPath is indeed Cisco's renaming and enhancing of Trill. So if you're familiar with Trill, that's the technology that we're dealing with here, just with some Cisco enhancements. So isn't it interesting that intermediate system to intermediate system, although a special layer 2 variation that we're going to be utilizing in FabricPath has made a comeback. ISIS, it's its big comeback. We know this particular link state routing protocol lost ground to OSPF dramatically in the race for dominance for a layer 3 routing protocol, but now it makes a bit of a comeback, utilizing a control plane architecture that we'll use in FabricPath for unicast, broadcast, and multicast packets. Now, spanning tree protocol. Let me elaborate on that in a moment here in this particular nugget. We are going to see that when we have a FabricPath domain, so there's our FabricPath domain and there's switches inside there, and we have a classic spanning tree, or any variation of spanning tree for that matter, domain on each side, we are not going to be passing BPDUs through the FabricPath infrastructure. Is there interaction between our FabricPath infrastructure and those spanning tree domains? Yes, there is. And again, I will elaborate on that later on in this particular nugget. Now, what about our VLANs that are not participating in FabricPath? Well, we call those, as you can see here, classic Ethernet VLANs. So we're going to be distinguishing between classic Ethernet VLANs and FabricPath VLANs in this particular technology. So what happens is we have our classic Ethernet VLANs carrying traffic from our classic Ethernet hosts to the FabricPath interfaces. And then the Cisco FabricPath VLANs kick in and carry traffic through the Cisco FabricPath topology. All VLANs that are meant to be forwarded over our FabricPath network need to be created as Cisco FabricPath VLANs. As you might guess, by default, all of our VLANs in the infrastructure default to classic Ethernet mode. For the routing of traffic that is going to multiple destinations, we have multi-destination trees that are going to be built in order to handle things like multicast dissemination of traffic. And we have FabricPath routing, of course. We have the ISIS protocol working behind the scenes in FabricPath, and it's building switch ID tables. These switch ID tables enable the routing of our FabricPath frames through the FabricPath network. There's conversational learning. This is a new concept that FabricPath introduces. It's new MAC address learning rules, and the reason they exist is to optimize the learning process within the fabric and really help conserve MAC address space on our edge switches. This new functionality occurs automatically for us in our Cisco FabricPath mode. And we don't want to lose another technology that we are excited about, and that's virtual port channels. So virtual port channels are enhanced. It's called Virtual Port Channel Plus technology, so that the virtual port channel concept can indeed function beautifully in the Cisco FabricPath network. Now let us elaborate a bit on the interaction with spanning tree protocol. In FabricPath, we identify edge FabricPath devices and spine FabricPath devices. The edge FabricPath devices, as you can see, might connect to classical Ethernet environments that are running some variation of spanning tree protocol. The first thing to note is that bridge protocol data units are absolutely going to be stopped from flowing into the FabricPath environment. There is absolutely no need for FabricPath to be carrying those BPDUs. In fact, what we will do is we will go to these edge devices and we will set the priority value on them to 8,192. This is really the only spanning tree configuration that we're going to make on these particular edge FabricPath devices. We ensure that they are the root for the spanning tree domain to which they are connected. What we can do inside of the FabricPath environment is we can carry topology change notifications inside the FabricPath messages. The TCNs could be utilized in order to carry from one edge device, let's say, to another edge device, the topology change notifications that need to be learned within a particular spanning tree protocol domain that is connected. But notice, we configure the devices as the roots of the spanning tree domains to which they are connected, these edge devices, and they will stop the propagation of BPDU traffic through the FabricPath infrastructure. So FabricPath functions through a simple encapsulation process. What happens is FabricPath is going to go in and it's going to assign, or we can do it ourselves, a unique switch ID to each of the FabricPath devices. So here you can see I've exaggerated the size of the edge devices compared to the spine devices, but this is all a nice FabricPath cloud, and we've got 2 edge devices in this particular cloud. Everybody's going to get this unique switch ID. Now, a frame enters the Cisco FabricPath network on this ingress edge device, and this device is in charge of encapsulating that particular layer 2 frame with, dun dun dun, a Cisco FabricPath header. There's going to be an outer destination address, and there's going to be an outer source address. The outer destination address is the edge switch, which is going to be the egress of this frame in this particular FabricPath cloud. And sure enough, the outer source address is the switch ID of this particular ingress frame. As you might guess, here at the destination of this particular traffic, this FabricPath header is de-encapsulated from the frame, and then it can be shot out to the classical Ethernet VLAN that exists in that particular area of the network infrastructure. So it is a simple yet powerful encapsulation process that is part of the magic of FabricPath. So I wanted to show you this encapsulation in more detail and really zero in on the FabricPath header. There's our classical Ethernet frame with its 802.1q tag that is further encapsulated. Obviously, we need a new cyclical redundancy check as a result of this. Notice there's our 48-bit ODA, our 48-bit OSA as we described, and then there is our FabricPath tag. Let's talk about the FabricPath tag first, shall we? Inside the FabricPath tag area, we have an ether type indication. Yeah, we have to alert the particular device that's carrying this what type of traffic it is, and that is an ether type value for Cisco FabricPath, which is in hex 8903. Then there is an F tag. The F tag is going to depend, its actual function depends on whether we're carrying unicast traffic through the FabricPath cloud or broadcaster multi-destination frames inside the particular cloud. If we're carrying unicast, it simply identifies the particular FabricPath topology we're on, but if we're carrying multi-destination frames, then the F tag is going to identify the particular tree that this frame should travel down. Now, what about like the ODA? The outer destination address portion. We know it's 48 bits. Inside there, we have additional fields like the sub switch ID. The sub switch ID is indeed utilized for Virtual Port Channel Plus. So this is a key ingredient to get Virtual Port Channel functioning in a FabricPath environment. There's also the port ID encoded in that particular field. The port ID is also known as the local identifier or local ID, and it identifies the specific physical or logical interface on which the frame was sourced, or of course, in the case of an ODA, is destined to. This field in the ODA, for example, allows the egress Cisco FabricPath switch to forward the frame to the appropriate edge interface. And it does this without requiring a MAC address table lookup. Pretty cool. Now there's other values encoded in here, but those are the big ones that are really critical for us from a troubleshooting perspective. Well, I suppose there's one more that's pretty darn important for me to mention. Inside the FP tag, sure enough, we do have a time to live value that is encoded. Obviously, the time to live is going to serve the same purpose as it does for us in our traditional IP forwarding environments. It's going to be decremented, and obviously, this is a loop prevention mechanism. Ingress Cisco FabricPath edge switches will set the TTL to 32 for all the frames that they receive. So before I get into some of the commands that you would use when troubleshooting common issues with spanning tree protocol, let's just go over some of the really most common problems. They're very simple for you to sort out with FabricPath. One of the things that could happen is you go to enable the feature and you can't. This is when you want to use show feature set to ensure that the feature set for FabricPath functionality is indeed installed and enabled. So that show feature -set that you would want to use at the command line. Another thing that can happen, of course, is that you are on a temporary trial for the FabricPath functionality. You get 120 days, for instance, under your particular license. Now, you will be getting a system message every day, once a day, telling you, all right, you've got 119 days left to have fun with FabricPath. All right, you've got 62 days left, etc. You can use show license usage to ensure that your temporary utilization of FabricPath is not about to expire. What if your interface won't take the FabricPath commands? Well, maybe you run an M series module. So watch out. Remember, this is going to be module specific. For instance, the F series would be required in order to take advantage of FabricPath functionality. What if you look at your edge device and you notice that the interface that is connecting to those classical Ethernet VLANs is in a blocking state? A spanning tree protocol blocking state. Yikes. What happened? Well, sure enough, superior BPDUs were coming in from your classic spanning tree environment, or your rapid spanning tree environment for that matter. So remember, we need to go in and set the edge device as the root. To troubleshoot this, we would obviously go into our spanning tree protocol environment and we would find out who is trying to take over as the root, and we would correct that. Also verify that you have set your edge device to be the root by setting it to the lowest possible priority. Finally, if you cannot switch layer 2 traffic across your Cisco FabricPath network, the most likely issue is that you have failed to configure the correct VLANs for FabricPath functionality. So we have show FabricPath topology VLAN active. This command can really help us out by showing us exactly what VLANs are active for our particular FabricPath environment. So in order to be a FabricPath troubleshooter, a bona fide FabricPath troubleshooter, we want to be able to do 4 things. We want to be able to verify basic parameters, obviously quite simple. Examine the FabricPath MAC address table. We want to examine the FabricPath routing table. And if you are indeed combining the functionality of virtual port channels with FabricPath, you need to be able to verify Virtual Port Channel Plus. So, four big commands that I'm going to utilize in order to verify basic Cisco FabricPath settings. Two are shown here, and I'll show you the other two in a moment. So, we mentioned it earlier, show feature set. Notice I can see that FabricPath feature set's been installed and enabled. Also, here we can see we have the FEX feature set installed, but it is disabled. That's unrelated to our discussion of FabricPath right now. Just wanted to show you the show feature set command and how we would easily be able to verify FabricPath is installed and enabled. Then we have the show feature set services FabricPath, and it comprises three services. Notice if everything is normal. We have our unicast layer 2 routing information base, our dynamic resource allocation protocol, and ISIS FabricPath itself. And then it is very simple to verify your FabricPath switch IDs. Remember, they can be created dynamically or statically on the devices, and the asterisk is going to indicate your particular system that you're running this command on in your infrastructure. So notice, very simple to verify the switch and system IDs of our FabricPath infrastructure. That's show FabricPath switch-ID. Then verify our VLANs. Critically important, since we know if we haven't included them in the FabricPath VLAN list, we're not going to have proper layer 2 forwarding across the FabricPath cloud. Show FabricPath topology VLAN active, as I alluded to earlier in this particular nugget. Here we can see that for our topology ID and name of 0, we have an active VLAN list of VLANs 10 through 30. So these are indeed our FabricPath VLANs that are capable of moving traffic across the cloud. So another step that we need to be able to accomplish, as we discussed, is to verify the MAC address table. And as you can see, this is very similar to in an iOS environment. We say show MAC address-table, and then here I'll specify the dynamic VLAN of VLAN number 10, for example. Now notice something very interesting here. Notice we have different output. In fact, notice there is an asterisk near each of these VLAN indications. This is a primary entry, it says. Here, look at these entries. Look at the format they're in. It's the format that we would expect. These are what we refer to as our local addresses from a FabricPath infrastructure standpoint. Notice that these local addresses are indeed denoted by the attachment port. So local addresses are our classic Ethernet interfaces. Cool. Then we have these addresses right here. These are our FabricPath remote entries. And notice they are in a different format. It's the switch ID, it's the sub-switch ID, and it's the local ID. Remember, we defined these earlier. We have our switch ID, the sub-switch ID, which would be used in a virtual port channel plus environment, and then the local ID. We said that was another word for the port ID. So the remote MAC addresses that are shown here are attached behind the remote switch that has the ID number 200. The sub switch is 0 because there's no virtual port channel plus bundle at the remote end. And then the remote interface has the local interface ID of 30. Remember, this identifies the exact source and destination port on a particular switch, and it simplifies forwarding by making an address lookup on the egress switch totally unnecessary. Now, there is routing going on here, as crazy as it is to say that at layer 2. And how would we view the routing information that's being used in the FabricPath cloud? Well, it's show FabricPath ISIS route. This is actually one way to do it. Notice this is going to show the ISIS topology in a manner like this. It's the switch ID and then how you would get there. So for switch ID 30, we'd get there via the port channel 30 interface. Notice there's a metric of 20 associated with that particular destination. And of course, this would show load balancing. Here, to get to switch ID 200, we can go and load balance across these equal cost paths. There's port channel 30, 40, 20, and 10 in this case, all with a metric of 40. Now, perhaps your deal is that you'd really like to see this layer 2 routing table presented in a manner that's consistent with a typical layer 3 routing table. Well, we have that option. Notice the command is slightly different. We're going to do show FabricPath route. In fact, the command's a bit more straightforward than show FabricPath ISIS route. So show FabricPath route, it's going to show things in a much more consistent manner for us. Notice we have the particular destination and then the number of next hops to get there, and then what those particular next hops would consist of. Notice we even have administrative distance, the age, the particular client protocol that is utilized to find the information, all presented in this more familiar presentation. Now, of course, with virtual port channel pluses, we want to verify those by going to another device in the FabricPath topology and verifying that we have our virtual switch ID and then the sub switch ID. So this verification is going to allow us to verify that virtual port channel bundle that's elsewhere in our particular topology. So an important nugget as we are troubleshooting the unified fabric, in this one particularly it was FabricPath. We reviewed the FabricPath control plane mechanisms, the data plane process, and then of course we got into a nice step-by-step of troubleshooting FabricPath with some powerful verification commands. This was after briefly discussing some of the more common FabricPath problems reported by Cisco's Technical Assistance Center. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.